Hello, this is Mrs. Boots. We're going to go through the practice problems for solving systems by elimination. So remember, we look for a variable that has opposite sign and same coefficient. So let's compare our x's. Our x's, we have a -4 and a -2. Well, they're not the same, and the numbers aren't the same, signs are the same. So let's go to the y's. The y's, I have -1 and -1. That seems a little bit easier. If I were to multiply the second equation by a -1, it would change the signs of everything in the equation. So the 2x would become positive, y would become positive, and the 11 would become positive. Once we do that, now my y's have the same coefficient, opposite sign, so we can add them together. I have -4 minus a +2 for my x, so that gives me -2x. My y's cancel out. Then I have -27 minus 11. Okay, so 7 minus 1 is 6. 2 minus 1 is 1. That gives me a -16. Now my x is by itself. I can divide by that -2 on both sides and solve for x. X equals 8. Last step. Now we actually need to plug it in order to solve for the y value. So it doesn't matter which equation we pick. I usually pick the one with the smallest numbers. So I'm going to take the second equation. Remember to use the original equation, okay? So I have -2. Now let's plug in that 8. For x minus y equals -11. Okay, so -2 times -8 is -16. And now we move that over to the other side by adding the 16. So I get -y equals 5. So we got to get rid of that negative sign, so y equals -5. We essentially divide by a -1. And now remember, the answer is written as an ordered pair. So I would have 8, -5. And that would be the solution for this system of equations. Number 2. Again, compare the coefficients. I look at my x's. I have a +4 and a -3. The only way I'm going to get those two numbers to match is multiplying both equations by something. So let's look at the y's. I have a +3 and a -6. This is a little bit better because I can multiply the top equation by 2 and I'd have a 6 in front of both y's. So let's do that. Top equation is going to get multiplied by 2. I'm going to write it right underneath so that I've set it up for adding. So 2 times 4x gives me 8x. 2 times 3y is plus 6y. And then 2 times 16 is 32. Now we can add the two equations together. The y's are going to cancel. My x's, 8 minus 3 is 5. So you have 5x equals -42 plus 32 is -10. So divide by 5 and x equals -2. Half the answer. Okay? Now we need to plug it in. Well, which equation do we want to use? Does it really matter? No. I'm just going to pick the top equation. So I'm going to use my top equation, plug in my x. So I have 4 times the -2 plus 3y equals 16. 4 times -2 is -8 plus 3y equals 16. And now we would add that 8 to the other side. 8 plus 16 is 24. Divide by 3 and I get 8. So my answer is -2, 8 for this particular system of equations. Number 3. Start by looking at the coefficients. The x's, I have a 2 and a -4. The y's have a 5 and a -4. So the x's, I would only have to multiply the top equation. With the y's, I'd have to multiply both. So let's multiply the top equation. What would I multiply 2 by to get a 4? Right, I would multiply by 2. Again, I'm just going to come right down below the second equation and write the top equation multiplied out. So 2 times 2 is 4, so I'd have 4x. 5y times 2, 10y. And then 35 times 2, 70. Now we're ready to add the equations together. Notice the x's cancel out. I'm left with 6y equals 18. Divide by 6, I get y equals 3. Half my answer. Now we need to plug it in. So which equation should we use to plug it in? I'm just going to pick the top one. Remember, if you modified it, you have to go back to the original. So I have 2x plus 5 times y, which is 3, equals to 35. 5 times 3 is 15, so 2x plus 15 equals 35. So subtract that 15 to move it over the other side, and we get 20. Divide by 2, x equals 10. Now I have a complete answer. 10, 3. Make sure you put the x and y in the correct order, and that is the solution for this system of equations. Number 4. Start by comparing coefficients. For the x's, I have a 3 and a 5, so I'd have to multiply both equations. For the y's, I also have different numbers, 5 and 4. I'd still have to multiply both equations. But my y's already have opposite signs, so I'm going to eliminate the y's. You could do it eliminating the x's as long as you multiply by a negative number. So the top equation I would have to multiply by 4, and the bottom equation I would have to multiply by 5. So let's do the top equation first. So I'd have 12x, 3 times 4 is 12, minus 20y equals 104. Okay, now let's do the bottom equation. We said we'd have to multiply it by 5. So 5 times 5, I'd have 25x plus 20y equals, and 5 times 31 is 155. Okay, so now we are ready to add them together. What's going to cancel? Yeah, the y's cancel. Add the x's together, we get 37x. Y's are gone, and I get 259. I divide both sides by 37, and x equals to 7. Now I can plug that 7 back in. Remember to plug it into an original equation. Don't just pick one at random. I'm going to use the top one. Okay, so my top equation, I would have 3 times the 7 minus 5y equals to 26. 3 times 7 is 21 minus the 5y equals to 26. Subtract that 21 and I get negative 5y equals to 5. Divide by negative 5, y equals negative 1. So my answer, my solution for this system is 7, negative 1. Number 5. Now we have 3 equations with 3 variables. You still start the same. Which letter can I get rid of the easiest? So compare your coefficients. For x's, I have 1, 4, and 3. I'm going to have to multiply, no matter what I add together. So let's look at a different one. Y's, I have negative 1, positive 1, and 3. Well, for 2 of them, I won't have to multiply. The third one, I will. That's okay. It's still going to be easier than the x. Look at z. I have 1, negative 2, and 4. I would have to multiply, again, all of them. So let's go with the y's. I'm going to label my equations A, B, and C, just so I can keep track of things. I'm going to take equation A and equation B because the y's are the same number opposite sign. And I'm going to add them together. So I write it out. Then I have 4x plus y minus 2z equals to 5. Let's add those two and see what happens. X's, I'm going to have 5x, y's cancel, minus z equals to 4. So I'm one step closer. Now let's look at two other equations. Notice in equation A, the y is negative, but in equation C, the y is positive. So what would happen if we multiplied equation A by 3? So if I take 3 times A and then add C to it. So let's multiply A by 3. We'd have 3x minus 3y plus 3z equals negative 3. Now I just write equation C down. 3x plus 3y plus 4z equals 16. Now we can add those two together. The y's will cancel. I have 6x plus 7z equals to 13. It's a little crazy, but when I look at the two answers that I've got, notice that in one of them I have a negative z, and in the other one I have a 7z. So let's take the negative z, and we're going to come up and multiply that by 7. So what would we have? We'd have 35 minus 7z equals to 28. Now let's go ahead and bring up the other equation so that we can add them together. So I have 6x plus 7z equals 13. When we add those together, let's see what happens. 35 plus 6 is 41. My z's cancel. And 28 plus 13 is also 41. So x is equal to 1. Now I can take that and plug it back into other equations. So remember that AB equation that we just used? Yep. We're going to plug the x into that and find out what z is. So I have 5 times 1 minus z equals to 4. So 5 minus z equals 4. Negative z equals negative 1. Z is equal to 1. Now back to the beginning. Let's look at equation A. I have x, which is 1, minus y, plus z, which is 1, equals to negative 1. So I'm using equation A. Let's simplify this. That becomes negative y plus 2 equals negative 1. Add the 2, or sorry, subtract the 2, and I get negative y equals negative 3. So y equals 3. Now I have my solution. Let's write it as a ordered set. So my answer would be 1, a 3, and a 1. That would be the solution for this system of equations. Number 6. First thing, label the equations. A, B, and C. Now let's look at it. For x's, I have negative 5, negative 1, 5. That has a lot of potential. For y's, I have negative 1, 2. For z's, I have 1, 1, negative 3. So the z's and the y's are a close tie. Either one of them could be easily eliminated. So I'm just going to take one A and B and add them together. But I need to change the sign, right? I need to make one of them negative. So I'm going to do A minus B. So I take my A equation, I'm going to write it down as is. Negative 5x minus y plus z equals 19. Now I'll change the signs of the B equation. X plus y minus z equals negative 1. Add together. For x is negative 5 plus 1 is negative 4. My y's cancel. My z's cancel. Wow, that's awesome. And I get an 18. And I just realized there was a mistake on my page. That 5x in letter A should be positive. So if that 5x is positive, this becomes a 6x when I add them together. Divide by 6, x equals 3. This usually doesn't happen. Usually I get a second equation. But that's okay because now I have x. I could plug it in to find one of the other letters, but I need to simplify and add some together in order to do that. So let's add together C and B. Only let's multiply B by 2 in order to eliminate that y value again. So I'm going to have C plus 2B. So twice B, that's going to be negative 2x minus 2y plus 2z equals 2. Now, the C equation. 5x plus 2y minus 3z equals negative 10. Add them together. Y's are going to cancel. I'm going to have 3x minus z equals to negative 8. Well, now I've got an x and a z. So I could plug in my x and solve. So 3 times 3 minus z equals to negative 8. 3 times 3 is 9. When I add it to the other side, I'm going to get a negative 17. Remember to divide both sides by z or by a negative 1. So z is positive 17. Now let's plug both of those into our B equation so that we can find y. So I would have negative 3 for my x minus y plus z, which is 17, equals to 1. Simplify, I have negative y plus 14 equals to 1. Move the 14 over, I have negative y equals negative 13. So y equals positive 13. Now let's write this as a coordinate, x, y, and z. X is 3, y is 13, z is 17. And this is the solution for this system of equations. Number 7. We have a money jar with nickels and quarters that are worth $2. So how much is a nickel worth? It's worth 5 pennies. So 5n plus, how much is a quarter worth? 25. So I'm going to have 25q, and that's going to equal to 200 because 200 pennies is in a $2. The money jar contains 16 coins. So I need to take my nickels plus my quarters equal to 16 because those are the number of coins that I have. Now let's look at it. Which one do we want to multiply by in order to get rid of it? I'm going to pick getting rid of the ends because it's smaller numbers. Multiply the bottom equation by negative 5. But let's write the top equation down first. So I have 5n plus 25q equals to 200. Now my bottom equation. Negative 5n minus 5q equals negative 80. Add them together. The nickels cancel. 25 minus 5 is 20. So I have 20Q equals to 120. So Q equals 6. Now I can plug that back in. So I know that the number of quarters and the number of nickels equals 16. So when I plug it in, I move the 6 to the other side, and I get 10 nickels. So remember, in word problems, we need to clearly label our solutions. I have 10 nickels and 6 quarters. Not just 10 and 6, and it's not an ordered pair. Number 8. The teacher gives you a test worth 100 points with 40 questions. Each question is worth either 2 points or 4 points. How many 2-point questions are on the test and how many 4-point questions? Okay, so let's say that A is my 2-point and B is my 4-point. I have 40 questions total. So A plus B is going to equal to 40. Now let's add our points in. 2 points for every A question and 4 points for every B question is going to get me a total of 100 points. Now we can determine how many question types there are. Which equation will we multiply by? Well, I'm going to multiply the top equation by a -2 in order to eliminate the A's. I usually pick the smaller of the two coefficients just to make life a little easier. So I'd have -2A minus 2B equals -80. Let's see what we get. Well, the A's are gone. 4 minus 2 gives me 2, so I have 2B equals to 20. So B equals to 10. So I have 10 4-point questions. How many 2-point questions would I have? Well, you do have to plug it back in. I know, it's common sense, right? But let me show you the math. So I'd have A plus 10 equals to 40. Notice I'm using my top equation. Subtract the 10, A equals 30. So I have 30 2-point questions. Number 9. Grain storage warehouse has a total of 30 bins. Some hold 20 tons, the rest hold 15 tons. So it looks like I have an A and a B again. So I know A plus B equals to 30. We're going to say that A is our 20-ton bins, and B is our 15-ton bins. Let's find out how many of each one we have. Now, how many total tons do we have? It says 510. So 20A plus 15B equals 510. Now we can multiply. Again, I'm going to pick the smaller of the two numbers. Smaller of the two coefficients. So I'm going to multiply my top equation by -15. Write it right underneath. So we have minus 15A minus 15B equals -450. Now let's add those together. 20 minus 15 is 5, so 5A, my B's cancel, and 510 minus 450 is 60. Divide by 5 and I get A equals 12. So there are 12 20-ton bins. Now let's plug it back in and find out how many 15-ton bins we have. So again, using the top equation, I would say 12 plus B equals to 30. Subtract the 12 over and B equals 18. So I have 18 15-ton bins. Number 10. We have a caterer's total cost for catering a party has a fixed cost, and he also has an amount for each guest. If it costs $300 to serve 25 guests and $420 to serve 40 guests, find your fixed cost. So I have two equations. One equation is going to be for my 25 guests. So fixed plus 25 guests was equal to 300. Now let's do the second equation. Fixed plus 40 guests equals to 420. Isn't that pretty? Now let's look at which one to cancel. I think it's obvious. Let's get rid of the F. So I'm going to multiply it by -1. Write it right underneath. So I have negative F minus 25G equals -300. So my F's cancel. 40 minus 25 is 15. So I have 15G equals to 120. Divide by 15 and I get G equals to 8. So it's $8 per guest. That's half my solution. Now let's plug it back in. I'm going to pick the top equation just because the numbers are smaller. So F plus 25 times the G was 8, equals 300. So F plus 25 times 8, which is 200, equals 300. Subtract the 200 over, and I get 100. So 100 is the fixed cost. Remember to always plug it back in and find the other solution. Number 11. Corey bought some neon fish at $2 each and angelfish for $3 each. He bought a total of 20 fish and spent $45. How much of each fish did he buy? So it's 20 fish total. So my neon plus my angel equals 20. Now let's do the ones with the dollar signs. I have $2 for the neon and $3 for the angel. And that was a total cost of $45. So which one do you want to get rid of? I'm getting rid of the neon. I'm going to multiply the top equation by -2. You could have multiplied the top equation by -3. I would get -2n minus 2a equals -40. My neons cancel. 3 minus 2 is 1. And 45 minus 40 is 5. So I have $5 for the angelfish. Is it $5? No, it's not $5. I have 5 angelfish. That's the number of fish he bought. Make sure we get our units right. Okay? Now let's plug it back in. So I have neon plus my angels, which is 5, equals to 20. Subtract the 5 and neon equals 15. So I have 15 neon fish and 5 angelfish. Number 12, last practice problem. Dan, Robert, and Brian are brothers. Okay, this should tell you that you've got 3 variables, right? I'm just going to use the first letter of their names as the variable. Dan is twice as old as Robert. So Dan equals twice Robert. Okay? Robert is 12 years younger than Brian. So Robert equals Brian minus 12. Remember, is the same thing as an equal sign. In 5 years, Brian will be twice as old as Robert. So we got to add 5 to it. So Brian plus 5 is going to equal twice what Robert. Now we get to have some fun. I would actually use substitution and not elimination with this one, just because it looks a whole lot easier. But notice these bottom 2 equations. we could, since they both have a B and an R, add them together. I just need to rearrange one of them. I'm going to rearrange the middle one. Okay? So, in my middle one, I've got to subtract the B. Actually, I need to rearrange both of them. Let's get them in order. Okay? So, bottom one, I would have B minus 2R, and that's equal negative 5, because I need to move the 5 over. In the middle one, I'm going to have negative B plus R equals negative 12. Do you see what I moved? I moved the B, moved the 5, moved the 2R. Now we can add those together. The B's cancel. I get negative R equals negative 17. So R equals 17. So R was Robert. Robert is 17 years old. That's good. The 17 is positive. If it had been negative, I would have known that I made a mistake, because there is no way somebody can have a negative number for age. Now I can plug Robert's age into the top equation, because Dan equals twice what Robert is, which is 17. So Dan equals to, 34. So that gives me Dan's age. Awesome. So which equation should we add in to find Brian's age? Yeah, let's use the bottom one. So Brian plus 5 equals twice Robert, which was 17. Okay, so Brian plus 5 equals 34. Subtract that 5 over, and I get Brian is 29. So Brian's 29 years old, Dan is 34 years old, and Robert is 17 years old. And this concludes all of our practice problems.